All right, let's go. Welcome everybody to my talk, to the last talk of the day. I'm actually surprised to still see so many people in here, despite there was beer outside. So I'm taking that as a good sign for now. My name is Manuel. I work for a company called Traefik. We are a German consultancy company, and where we do things with and for our customers. I joined Traefik back in March. I previously worked for 2 startups within the cloud-native API gateway area. First, I worked for Traefik Labs, where I'm maintainer of the well-known proxy Traefik. And afterwards, I worked for Solo.io, which Lynn, when she had her talk earlier, you already had that kind of intro. So today, we're going to look at Gateway API, the new rising star in cloud, or actually Kubernetes native API gateways. I think I'm the 4th person which has something about that topic or a talk about that topic. So looks like it's a good one these days. For today, I just have 5 quick points to walk you through. So first, we're going to take a brief look on what's actually an API gateway. Then we try to define what Kubernetes native actually means, how this thing is currently, how the current landscape looks, what actually the Gateway API is, for maybe there are people that don't know yet, and then a demo where usually something screws up, no matter how often I try that, something usually fails. So let's see if that history will continue today or not. So for what's an API gateway? Just a brief one-on-one, because I'm sure most of you, if not all, already know that, and I've taken a picture from the Microsoft docs. An API gateway is a central service in architectures these days between client and services, and it just sits in the middle there. The good part about it being there is, and we heard that today, I think in at least 2 talks already as well, that it's like a central point, right? So if you want to make sure or need to ensure things like security or rate limiting or all that kind of things, that API gateway can take care of it, because you can just offload all those functionalities to the gateway rather than having to re-implement all of those things inside your actual services, your microservices, whatever you're working with. And because this is such a central component, there is a lot of areas and features where this can potentially where it can take actions like traffic management, routing, load balancing, TLS handling, all those things. And this component, if we look at it from the earlier days, it kind of evolved. If we look at the first API gateways, they weren't really Kubernetes native at all. You still had some things to define, in UIs or whatever, right? Or special databases as broad or whatever. But over time, those just evolved. And if we try to define what Kubernetes native actually means, I'm trying to think of it in 3 different pillars. First, whatever it does, it needs to work with what Kubernetes offers, right? So it needs to work with its APIs, its resources, its features. Kubernetes really brings a lot of features to the table that an API gateway can just reuse, things like leader election or service discovery or whatever be it, right? And then for Kubernetes in itself, and therefore which applies to this topic as well, I mean, eventually, it's just walls of YAML files, right? It's just declarative configuration pasted into YAML. So whatever we do, it needs to work with that. And last but not least, and I think that we heard multiple times this conference already as well, if we look at the CNCF landscape, this thing is huge, right? And while it's huge, that allows for extensions in the ecosystem that, if you do an API gateway, you can leverage. So you don't need to do anything or everything by yourself, because you can just reuse it. But therefore, you actually need to have the technical capabilities to reuse it. And if we look at what this actually means, I just picked a handful of components, because otherwise the slide would be a bit too full. So if we talk about actual components, there's so many things an API gateway needs or should work with in this landscape. So you have deployments where it will probably be deployed as. You have Gateway API for the configuration. You have CRDs inside Kube for specific configuration, which might not be part of a gateway API. You have things like operators, secrets, which potentially can host the TLS certificates and all that kind of things. So there's really a lot of components that if you build such a solution, you need to take in mind and you need to just use. Otherwise, you can't really claim you're a Kubernetes native. And if we look at how the history unfolded is that at first, when those API gateways were still called Ingress controllers, because we all love buzzwords, right? We started to put like the hell of annotations on Ingress resources, but then things just got super messy. If we look at that example, and I know that the guys in the back probably won't recognize all of the annotations, but seriously, it doesn't matter. This is just to ensure or to showcase how things were in like the old days. If we look at Ingress, which was or still is, the traditional resource in Kubernetes to get HTTP routing going, this is where we ended up. And we ended up there because things were just complicated. Like for simple cases, let's say I have a host name, I have a path or something like that, right? I really use simple stuff like that. This resource really worked. But we all know, or at least I think that most of us know, is we all have different configuration requirements because we need to configure different things. Let it be buffer sizes, let it be rewrites, let it be redirects for non-HTTP traffic to non-HTTPS traffic to HTTP traffic and things like that. And the only way to stuff that on Ingress resources was like this madness. Like this was just like a massive amount of annotations. Technically, annotations are just key value pairs, so essentially strings. Which became super messy for like the end users because it's like a hard vendor lock-in. Like this annotation would have worked on an engine X Ingress, but if you would have gone for, I don't know, HA proxy, for example, you would have had to redo all of the annotations and all of that. So it's super messy for the actual end user. It's crazy messy for the maintainers having to maintain this string value key mess, because it just does things. So it was really not optimal. And then and I remember that pretty funnily, back in 2019, some guys from Google showed up in my email inbox because I was still working at Traefik at that point in time, and we're like, hey, we want to build a new API. We want to kind of build the Ingress v2, what they called it back in the days, and we're asking for like all of you guys that do that on a daily basis, let's define an API that works for your cases. And that's when all of this started, because in the interim, because people were like tired of this, every Ingress controller started to build their own CRDs to do configuration, which was bad because then they dropped out of the ecosystem. So this started, or the movement toward Gateway API started in the end of 2019, and in October 2023, back in Chicago, that thing actually was called GA. So what is the Gateway API? For me personally, it has three major enhances, or actually four if you want to go for that, but there wasn't enough place. First off, and this is pretty nice, the Gateway API in itself is just distributed as a set of CRDs. So by that, therefore, it is really dynamic. Like it's not bound to the regular release cycle of Kubernetes and things like that. I don't know who of you actually tried to like contribute to Kubernetes upstream already, but if you know, you know, or if you did, you know how much pain that is. So just by having like CRDs that are distributed separately, users can decide whether or not they want to opt into using them, and if they want, they just put them to the cluster, case done. Secondly, as I already sneak peeked, this one was built on the shoulders of giants, basically. So when this API started to be designed, everyone who had like experience in this area, and back in the days, most specifically, it was Istio and Contour, because they had like the mass majority of adopters. All of these experiences were taken into account. And for the third part, and I think Simon said that in his talk yesterday already, this Gateway API allows for separation of concerns. With the traditional Ingress API, everything was this one resource. It was crazy complicated, doable but crazy complicated to separate who can do which things and which actions and which configuration and all of that. And this API set allows for separation here. If we look at how things differentiate, this is the basic world of Ingress, right? Like you have your client, there's an HTTP request to the load balancer. Then you have your Ingress resource, which has a routing rule like hostname equals something and path equals whatever. And then the requests get forwarded to the service, and from the service eventually to the pod. I mean, I think we all know that. If we look at Gateway API, there is like one change in between, and this is what allows for the separation. There's still stuff coming in, but now there is not one, but two resources. A, the gateway, and secondly, the HTTP route in that scenario. And after the HTTP route, things go to the service or the pod. But what are those resources actually? If we look at the resources, there's different personas that we tend, or with the intent that different personas use those resources. What we first have is a gateway class. A gateway class is kind of like a template for a gateway controller, let's say. So a gateway class could be Cilium. A gateway class could be Traefik. Like every controller that is there has like a gateway class, and that holds some sort of configuration. And typically it's expected that infrastructure providers could already have gateway classes present on the clusters, and then users, like their end users, can decide which gateway to use. The gateway is expected to be used by cluster operators because the gateway offers configuration for things like TLS, for example, which TLS version, which TLS ciphers, like all those administrative things that potentially an operator's team or an operator wants to just take care of, and he wants to control by himself. And then last but not least, for the other layer, then there will be the actual routes, like the actual route types, let's say, which is what we expect to be used by the application developers. And as you can see, there's different, or as you can guess, there's different amount of routes. So we have like a TLS route, which is kind of like a TLS pass-through thingy. We have an HTTP route, which is a regular HTTP traffic management component where you add a bit like traditional Ingress, but on steroids, let's say. So there's like different route types for different cases, but therefore you can like totally separate those concerns and do whatever you want to do, basically. If we look at the Gateway API and how this is distributed, there is also a difference, which is possible because of the distribution as CRDs. The Gateway API itself is distributed in two different channels, namely standard channel and experimental channel. The standard channel is now available in version 1.1 as of last week or something like that. And this features like four major CODs. One is the HTTP route. We saw that already, and we go into detail here soon. We have the gateway class. And as of 1.1, the second route type made it into GA, which is gRPC route. For the experimental channel, that's kind of like all things the API tries to solve, but there's no stability guaranteed within like the CRDs yet. Therefore, things are in the experimental channel, and there's more route types, for example, or more other features available in this channel. But since it's just CRDs, it doesn't really matter. Like when you want to adopt it, you just pick the channel you want to use, and then you get the resources you want to have and can do whatever you want. What is also pretty new about the Gateway API, and that is, I think this is one, if not the biggest learning after the separation of separation of concerns thing. Gateway API in itself is open for extensions. And what do I mean by that? If we look at an HTTP route, you have your normal configuration, right? You have your host name and all that kind of thing. So we all know that from Ingress. But then there is a way to extend what the API gives you but in a standardized manner. So if we look at the layers, there's the core layer, which does or allows for things like hostname matching, for example. And then there is an extended layer where products or projects supporting Gateway API should supporting that, but there is no guarantee. And things that are not guaranteed then, for example, are some specific filter types. Filters in terms of an HTTP route in Gateway API is a way to edit your HTTP response, or request. So for example, things like a TLS redirect would be a filter. A rewrite of a path would be a filter, like everything which is to be done before the request reaches the service. And last but not least, and we will see that in my demo as well, there is also a way for implementation-specific extension of the API, but you still stick within the API. What I mean by that, I'll show you in the demo, because otherwise it's a bit too abstract, I think. If we look at who currently implements this and what is like the integrations about it, there's like this thing is growing rapidly, and I think you already guessed that. As I said at the beginning, I'm the fourth person to talk about that. All major Ingress gateways like Cilium, Kong, and all of that, Traefik, they already support that, so that's fine. We have other systems in the ecosystem, such as cert-manager or cert-manager or external-dns, all that kind of things. They all support it, and that's great, because that's what, for us as a community, for us as an ecosystem, having a standard that people or end users on the one hand want to use again, and on the other hand is actually adopted by the persons that provide tools in that ecosystem. It's just like one more point to focus on. So with that being said, because that was like very theoretically, I will take you into the demo. And as I said, usually that ship breaks somewhere in between. So let's see if it will go through this time. For my demo setup, maybe as like a quick peek. Let's see if that's actually, I make it a bit bigger. Is that okay for the back? Yes, okay. So what we'll see in the demo is I already have a cluster prepared. It's a simple K3s cluster, nothing crazy. There is a Traefik installed as like the gateway controller. We have external DNS running to provision external DNS entries, and cert-manager to get TLS certificates for my things. So, and I have two dummy applications installed, just like a simple who am I application and a simple where's my who am I there, a simple who am I and a simple HTTP bin. And there's some other stuff installed, but like don't care for now. That's like not really important. So what are we going to do? First off, we have this gateway, right? It's a gate or even one step before. We have a gateway class. In this cluster, I actually have 3 gateway classes just to like show the concept, right? Because that's potentially gateways that we could use within this cluster. Then I currently only have one gateway available. Let's make that a bit smaller, then it's a bit better for the back. Potentially. We have one gateway available in the cluster. As I said, that's my Traefik gateway. It has an address, so it's like publicly reachable, no problem. What you can configure on a gateway is these so-called listeners, which kinda is like the port it's listening to, and you can give it like the protocol and an arbitrary name, what you want this listener to be named. In my scenario, that's just a simple HTTP listener, so no problem. I also already, because I prepped a bit of that, because sometimes usually DNS fails, so I tried to like overcome that DNS issue. There is also an HTTP route already available in my cluster. This HTTP route has a host name of api.example.cloudnativerocks. and I link it against my gateway, and that's one of the parts about separation of concerns. Like this kind of says, hey, I want this HTTP route binds against a given gateway. But as we have seen on the gateway, there was this allowed namespaces thingy. Gateways can restrict who is actually allowed to bind them because, as I said, it's all about separation of concerns. This time it worked out, though. And then for the actual routing part, I have a routing rule, which is just a simple /get. And if a simple /get is called, I want this to be forwarded to the HTTP bin service. So just a simple curl, HTTP API example.com, blah, 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 /get gives, maybe I should do remove the -v, then it's a bit more readable, and we have the response. So that's like, that simple routing, nothing really crazy about that. So let's do the first thing that I want to show. Secondly, I have an HTTP route here, which kind of gets to the second level, and this is actually a bit more complicated. First off, we are now not only listening on /get anymore, but we also do listen on /whoami now, and I want to actually do things with this request. Therefore, I add a filter of type URL rewrite, and what this URL rewrite filter does is, why are there help messages everywhere? Holy moly. What this rewrite filter does is it takes the request, it rewrites the host name to foo.bar prior to forwarding it to the actual service. And also, I wanted to replace the prefix match, meaning before it gets to the service, I want that it removes the /whoami and replaces this just with a simple /. That's the beauty about filters. Like, there's ways to manipulate kind of what to do prior to forwarding it. So if we go back to the shell, I apply that. Rewrite, there we go. Now the HTTP route is there. So if we look, there's the fixed route now here. Foo.bar, blah, blah, blah. So I go to my URL. I call not /get, but rather, what was it, whoami? And we see the response from the service. What we can see here is that it did what I told it. So it replaced the path. There's still like the old path in. The host name reaching the request is now foo.bar, and it reached it on /get. So works, magic. And if we just look at this and compare that to previously about how many annotations I would have had to stuck on that Ingress resource, that would have just been like a wall of strings, basically. And now this is actually like available. Last but not least, because as I said, what is also pretty huge is the amount, or the capability, better to say, to extend this API, and that's what we're going to do here. What I do, or what we do, is we will use a filter of type extension ref, and that means that you can basically tell through the gateway API to use whatever arbitrary CRD that is present in my cluster. In my scenario, I give it CRDs from the Traefik controller, which is the one which adds a basic authentication to my application, and second, which gives a rate limit. And if we look at the actual CRDs, that's just as usual, like regular YAMLs, right? That's a middleware thing. It has a secret with the total secure user password combination. And for the rate limit, it's just like a simple rate limit. So nothing crazy about that. So I quickly apply that as well. If we look in here, there is now the next HTTP route, which has all that configuration. So if I just go for it with the regular call, we get the 401 unauthorized. So we are not allowed to call that resource. If I now give it the complete configuration with the user and the password, we get through as expected. and if I do it a couple more times, we get the 4 to 9, too many requests, rate limit kicked in. And that is, while it looks pretty simple, that's pretty sweet, because we are able, with this API, we are able to extend to all use cases you might have in mind, but you still stay within the ecosystem. Because from the API point of view, it's still HTTP routes. So things like cert-manager, external-dns, and all that things, they can still work. I already pre-provisioned, because time, I already pre-provisioned a TLS certificate for this domain through cert-manager. So all I need to do now is, and this is the YAMLs file for Traefik, all I need to do now is to run a simple Helm upgrade to tell Traefik to actually use this, certs that are already provisioned. And if we look at the gateway resource, we now see that there is a second listener available, which now listens with the protocol HTTPS and has a reference to the secret holding the certificate. So if I now do my curl request, and now I do HTTPS rather than HTTP. Oh, that was the wrong one. OK, let's do it here. Rather than HTTP, we pass with HTTPS, and all is good. This is the end of my talk. I have 2.5 minutes left for questions. If you have questions, just ask. Otherwise, I'll be here a couple more minutes after the talk, but then I need to catch my train. Thank you very much.
So thank you for the great talk. My question would be, so you can, as you showed, you can have multiple filters. Is there a way to do like a filter pipeline, basically? Like in
kind of like an ordering?
Yeah, exactly. Yeah, like in which order will the filters will be applied, basically?
And it's as simple as you could have guessed. It's the order.
Okay.
You put it in the YAML file.
So the thing, like the list is not as you put it in, it's just sequentially executed. Okay. Okay. Yeah, that's everything.
There. There also. Sorry.
Thank you for the talk. Like you mentioned, the concern has been separated. Now the load balancer vendors have to implement their gateway resources. So the filters are specific to those vendors now?
Well, there is, like I said, there is filters that are like available by default. For example, URL redirect, like redirecting something from HTTP to HTTPS. That's just part of the API. Like you then set this type URL redirect, and this will work across vendors. But not every, like for filters that are marked as extended, there it's not guaranteed that every filter does support it yet. But in a case where it's not supported, then you can use what I showed last, this extension thingy, to just tell it what to use. But then this is obviously like vendor specific, because they have different configuration options.
So we should look into the vendor documentation for those. Okay, thank you.
Sure.
Somebody asked you.
On the right.
Okay, thank you for the presentation. My question is, can this HTTP route or whatever resources can be utilized for some sort of canary deployment?
Yes.
Yeah.
There is like a weighted round-robin deployment pattern and things like that just built into the API. So you can do like canary deployments just by the API, and this is already part of the core API. So this will work across all gateway API controllers.
So, I mean, this is only possible at the edge of the cluster sims, but if you want to do it more, not something like service mesh everywhere, but is it possible you deploy more gateways and then you do kind of a tiered implementation?
To chain gateways, kind of?
Yeah, to have multiple gateways in the cluster where one acts as the edge and the other two just distribute based on,
You can have as many gateways as you want in your cluster, and then you would just limit them by the namespaces, for example, like who can read configuration from which specific namespace, and then you can build your tiered architecture by separating them.
Nice. And the last question is that in most of the microservice architectures, you have some sort of authentication service or authorization service, let's say like Keycloak, and then usually vendors, they come with their own, like for example, Traefik, they comes with their own middleware of how to talk to this. But how it will be if you have gateway API?
So authentication is something that's still being discussed because it is so hard to find a consensus. But the overall goal is to have like an authenticated, then it's not a filter, then in terms of gateway API, it's called a policy. Then you would attach an authentication policy to an HTTP route, kind of like as a separate CRD. And then all routes that have this policy attached would go into your, you said Keycloak, I think, to your Keycloak first for authentication. But that is something which is not part of the API yet, but that is something which is heavily discussed. I personally expect that to land relatively soon, at least in the experimental branch, to go for it.
Yeah, thank you.
Sure. Any more? Thank you very much.